Sunflowers and heliotropism. Introduction. Heliotropism is a dynamic process in plants, specifically sunflowers, where the plants follow the movement of the sun across the sky to optimize light absorption for photosynthesis. This process relies on the plant's ability to sense sunlight direction through specialized photoreceptors. By examining heliocentrism as a dynamic process, we can track its inputs, outputs, feedback mechanisms, and control processes.
Next is the features of the system, which include leaves/flower heads that track the sunlight, stem that acts as the support and control point of movement, photoreceptors that detect the sunlight direction, auxins, which are plant hormones that drive the growth to orient the plant to face the sun, and, of course, the sun. For equations of motion and how it grows, the dynamics of the system involve a differential growth of plant cells on opposite sides of the stem. Growth is controlled by unequal distribution of auxins, which can be found through this equation, delta L equals K times delta C times T, where delta L is the differential elongation of stem tissues, K is the growth rate constant, delta C is the difference in auxin concentration in the stem, and T is time. The growth is what causes the plant to bend toward the light.
A study from UC Davis found that sunflowers track the sun's motion during the day and return back to their normal position during the night. This dynamic control system has inputs of the light intensity as well as the angle of the sunlight, and the output is the angle of the sunflower's orientation relative to the ground.
Control law. The sunflower system behaves like a P control system because the growth rate is proportional to the angular error between the head and the sun. There is even a reset mechanism at night when the head resets eastward via circadian rhythm. Our set point is the sun position, our controller is the stem actuator controller, and our system is the sunflower head. Our feedback loop is our measured sun position, and disturbance is the cloud cover/wind.
The ENU coordinate system, which stands for east, north, up, is ideal for describing how sunflowers track the sun throughout the day. In this system, the east axis represents the local horizontal direction towards the sunrise, the north axis points towards geographic north, and the up axis is vertical perpendicular to the ground. Sunflower heliotropism primarily occurs in the east-up plane, as the sunflower tilts eastward in the morning and follows the sun westward by evening. Using the ENU frame, we can quantify the sunflower's orientation by measuring the angle between its head and the vertical up axis, dynamically adjusting as the sun's position changes in azimuth and elevation throughout the day.
The sunflower is a continuous system because it is constantly moving to adapt to the sun's position in the sky. The process is a negative feedback loop. As the plant bends towards the sunlight, the light intensity becomes more evenly distributed across both sides of the stem. This reduces the light gradient detected by phototropins. With less gradient, the redistribution of auxins slows down, reducing the rate of cell elongation on the shaded side. Once the plant is fully aligned with the sun, auxin transport returns to a balanced state and growth rate equalizes on both sides of the stem. This negative feedback ensures that the plant does not overcorrect its orientation or waste energy on unnecessary growth, maintaining an efficient and stable tracking mechanism.
Ode to a sunflower. There's one special plant that comes with this power, a dynamic system called a sunflower. With a green stem and yellow petals, they turn their heads as the sun settles. Adaptive control is the superpower of our beloved sunflower. From east to west, their petals trace the sky with movement slower than the human eye. Equipped with a mechanism to grow steady and strong, sunflowers use heliotropism before their stems get too long. Growing on one side and then on the other, watch as they glide, dancing with each other. We thank the sunflowers and we thank Dr. Madhu for teaching us everything and all that you do.
Thank you!